All right.
Yeah, I started it. Yeah.
Okay, so while Ajay is looking for his file, I'm going to go ahead and share this document we mentioned in the lecture on higher RAID levels about why we have fake drives and fake stripes. So just get that out of the way. Anyhow, so if we start looking at RAID DP volume, in this case, we build a RAID DP with 7 drives. That means that the underlying RAID 4 volume only has 6 drives, which 6 is not a prime number. If we kill drive 1 and 4, those are 3 drives apart. So when we start looking at the drives, we see that diagonal stripe 0, 1, 3, and 4 are dead. Only one diagonal stripe is degraded. And so we can start rebuilding from that. We can rebuild this, we can rebuild this, but then we stall. And the way that they fix that, so we can't, there's no place to go. Once we've rebuilt this drive, it's on that non-existent stripe because we've got modulus on that. And so what we do is we add a fake drive. In our examples, we just would add another drive and just fill it with zeros. In the actual thing, of course, you don't have to go out and spend the money for a real drive. By doing this, now we have a prime number. We do this, we still see now that we have 2 diagonal stripes that are degraded. We're able to rebuild. The first one still stalls the same place, but the other one, we can then start rebuilding from the other direction. And it goes backwards, 4th, 5th, 6th, and so on. And so it can meet in the middle. So brief discussion of why that is the case. And we'll go ahead and go into more detail if people have any questions about it. All right, I'm done. I'll stop sharing my screen here. And Ajay, are you ready to go again?
Yes. So we also have a project for the next week. We'll start the project after the midterm. So what I suggest for you guys, just go there and club with your team members, which I'm going to share you the instructions on Blackboard with the link for Excel sheet as well, where you can go there and write your team name beside your name. So we'll do that. And we also have a column saying if you're looking for a team, write yes or there or something, which will post instructions on the Blackboard. So we are going to start with our project after the midterm. But before the midterm, we highly encourage you to form the teams. So I'll share the instructions in Blackboard with the link. You can go there and write your team name. Okay. So each team will have 3 or 4 members. Again, that's in the instructions. So let me start sharing my screen first. So these are the primitive polynomials. So let's just try to build a logarithmic table in this. So do you guys have anything in mind to use to build a logarithmic table? So you can go there and ask me about 19, 25, or 31. So if you have anything in mind, we'll do that. Or I'll just go there and solve it for x power 4 x cube plus 1, index 25. Yeah, solve it for power 4 plus x cube plus 1. Let me share my other screen for you guys now. Oh, are you guys able to see my screen?
I can see your screen.
Okay.
I'm not seeing your iPad. Oh, this is your iPad now?
Yeah, it's my iPad now.
Okay.
Get this out of my way. So x power 4 plus x cube plus Yes, what's that?
Yeah, we're not seeing the.
X cube plus 1. It's doing some funky things. So primitive polynomial x power 4 plus x cube plus 1. So 15.
Yeah, I'm not sure.
Oh, it's not sharing.
Happening. It's stuck on the screen where you're starting it. Now we've got tree trunks. That's your
Oops.
desktop.
Yeah, that's my desktop on iPad. So I guess it's better idea if you're gonna explain the logarithmic table to people, I guess.
Okay.
If you can.
Let me go ahead and
I'll
do
stop
that
sharing.
then.
I'll stop.
All right, I can go ahead and share using Paint file.
Yeah, that would be easy. Yeah. I'll mute myself.
Let me go ahead and share this screen here. We'll make a nice large area. So we want to do, I don't know if it's better to use.
X cube plus x square plus 1. X power 4 plus x cube plus
4 plus cube. Okay. X 4 plus x cube plus 1, that's 16, plus 8 plus 1 is 25, right?
Mm-hmm.
All right, so that's the thing we're going to do now, right? All right, so what we want to do is to start building our anti-log table. So, you know, it might be better to just do this in an Excel spreadsheet. What do you think? I'm going to try to do this here.
Okay.
Make my font nice and big. Hey.
Today, I tried to show it on whiteboard, but the camera didn't work yesterday.
So if we're starting with n and 2 plus n, we're going to make our anti-logs first, right? And this is also called the anti-log. And then, of course, this will be the log over here, right? So we're going to start with n starts with power 0. Oops, 65. So we've got 0 through 15 because we've got a size of 16 is our table. So we're going to go through 0 through 15. As we start building it, 2 to the power 0 is 1. 2 to the power 1 is 2. 2 to the power 2 is 4. 2 to the power 3 is 8. 2 to the power 4 is 16. This is too big, right? So we're going to move this over here. Now we're going to XOR this with, again, 25. What is 25? Is 25 equals 16 plus 8 plus 1. In binary, that is 1, 1, 0, 0, 1, right? Yes. So, of course, as our value gets out here, this is the 16s bit right here. So when we hit this 16, we're going to have that first term is going to turn off the top bit. And then we're going to turn on bits in the middle of the thing to make sure that it doesn't wrap too soon. If we just were to use, you know, modulo 17 or something, it would, or no, I guess 17 is good, right? Anyhow, so we're going to go ahead and XOR 16 with 25. So 16 is 1, 0, 0, 0, 0. And then we're going to XOR that with 1, 1, 0, 0, 1. And when we do that, of course, that'll just turn off that top bit equals 1, 0, 0, 1, which is 9, right? Now we're going to double 9. We're going to get 18. That's also too big. So 18 is 1, 0, 0, 1, 0. We're going to XOR that with the same thing, 1, 1, 0, 0, 1. And that's going to bring us down to This will give us a 1 here in the 8s, 0 in the 4s, 1 in the 2s, and a 1 in the 1s, right? So this turns into 11. Okay, so we're going to fill in an 11 here. And if I'm doing this wrong, stop me, right? We double this, we get 22, which is also too big. 22 is 16 plus no A's plus 4 plus 1, right? So 16 plus 4 is 20, and then 2 more is 22. We're going to XOR that now with 11001, and that's going to give us the result of 1111, right? Because we have XOR here, there's only one bit on here. There's only one bit in the 4s, one bit in the 2s. And so this is going to be 15 in decimal, right? So 15. We're going to double 15. We're going to get 30, right? 30 is 16 plus 8 is 0. Should be 11110 because 31 is 11111. We're going to XOR that. How am I doing here, Ajay?
Yeah.
With the same primitive polynomial. In this case, the top bit is going to be a 0. We've XORed off, of course, the 16 bit, but the 8 is going to be 0. At 1 XOR 1 is going to be a 0. We have a 1 and a 1 and a 1, so it's going to turn into a 7. 0, 1, 1, 1 equals 7, right? So our next number is 7. We double 7.
14.
Yay, we stay in range. 14 is good. We haven't gone out of bounds. We finally managed to stay in, doubled without going out of bounds. Now we double 14, we get 28, right? 28 is out of bounds. What's 28? Well, 30 minus 2, 1, 1, 1, 0, 0.
0, 1. Yeah.
Or 1, 1, 0, 0, 1. And so we have a equals 0,
1, 0,
and
1.
then 1, and then a 0, and then a 1. So this is going to be, right? Oh, this is a 0, 0, 0, 1, 1, 0.
0, 1, 0, 1, yeah.
0, 1, 0, 1. And so this is a 5. Okay, so we've got down here, we've wrapped ourselves back in, we've got a 5. So far, so good. We're filling out this field nicely. 1, 2, 4, 8, 9, 11, 15, 7, 14, 5. 5 doubled is 10. 10 doubled is 20, right? 20 XOR 25. 1, 0, 1, 0, 0 is 20. XOR 1, 1, 0, 0, 1 is 25 equals 1, 1, 0, 1.
0, 1, yeah.
Right, which is 13.
13.
And as we are hoping, we're wrapping ourselves back into the field, calling in numbers. And you notice that every time we wrap back into the field, we had a 16, we wrapped in it turned odd, turned to 11. We wrapped 11 back in after we're going for 30, it comes back out. Every time we wrap back into the field, we wrap in as an odd number, which makes sense because we've just multiplied by 2. So it's always even. This is why the number has to end in a 1. So we make sure that we fill in our odd numbers. So every time we wrap back into the field, we make sure we pick up another odd number. 13 doubles is 26.
26.
Yes. 1, 1, 0, 1, 0.
0, 1, 0.
Yes.
XOR 1, 1.
And we get 0,
0, 0,
0,
0, 1, 0.
1, 0.
So 1,
0, 0, 1, 0, right? Nope. 0, 0, 1, 1.
1, 1, yeah.
Yeah, yeah. This is off, this is off, this is on, this is on. So again, we're just checking to see where the two numbers are different. And this is 3. Right? So we get down here, we plug this in a 3. Now we double to 6. We double to 12. We double to 24.
4.
4. XOR 24 is 1, 1, 0, 0, 0. XOR
1, 1, 0, 0, 1.
Hang on, I messed up this. It should be a XOR. Smiley face. Yeah. Okay. And this should be also an XOR.
Mhm.
Sorry. Okay. Now we're down here. 11000 XOR 11001. And this is going to be equal to 1.
Yep.
Okay. And so as we expected, we wrapped around at the back of our field, our finite field. We expected that last number to be a 1. Okay. So we've successfully built that finite field anti-log table. And now in order to build the logarithms, we simply find each number in the anti-log table, 1. We fill in the n that was associated with it. So the anti-log of 1 is 0.
0.
The anti-log of 2
1
is 1. The anti-log of 4 is
3
2.
is
The
12.
anti-log of 8, because we got here, now we're going to go down to 3 here. For 9, we're going to put in a 4.
4. 11, 5.
For 11, we're going to come down here. We're going to put in a 5. For number 15, we're
6.
going to scroll way down here and put in a 6.
7, 7.
We did 7. We're going to go 7, 7, 7. Yeah, lucky 7, triple sevens. 14 is going to turn into an 8. 5, we go back up here. That'll be a 9. 10 is going to be a 10.
Yep.
13 is going to turn into an 11. 3 way
12.
up here is going to turn back to a 12. 6 is going to turn into a 13. 12 is going to turn into a 14. And we filled in that table. This number, of course, is negative infinity, right? For complain, Microsoft Excel, shush, I don't care. Yeah, anyhow, so so that is our full log anti-log table for a finite field of size 16, 2 to the 4th, with the primitive polynomial is 2 to the 4th plus 2 to the cube plus 1. We go back to our Terrible slides that Ajay has up, and we could pick any size slide. Of course, if we go into our Jupyter notebook, we can go ahead and ask it to build this for us automatically and verify our work. So if I go to Jupyter, here.
Before that, could we see the multiplication?
Oh, the multiplication table? Yeah, okay,
yeah,
sure.
Yeah.
So what number do we want to multiply? We're just going to go ahead and do the multiplication here, or are we going to build
multiplication,
the table?
Yeah. No. Just do the multiplication, like 8 times 5 or something. Yeah.
8 times 5. Okay, so 8. 8 times 5. Hello. 8 times 5 equals, oh, we better turn that into a string.
Yeah.
Right? So if we say 8 times 5, we're going to take log is going to be the log of 8. 8 plus log of 5. And we're going to take that whole thing and we're going to turn that into the anti-log. Right? So the anti-log of log 8 plus log 5. So we find 8, that's 3. We find 5, that's 9.
9.
So you get 5 plus 9, right?
It should be 3 plus 9, right?
Wait. 8, 3. Yeah, I'm sorry. 3 plus 9.
Yeah.
3 plus 9. Oh, you're going to make it easy on me here. So we do the 3 plus 9. We take that and we don't go outside the field, so we just get 12, right?
Yeah.
And now we take the anti-log of 12. So we find 12 in our table. We do the anti-log and we say it's 3, right?
3, yeah.
12. So 8 times 5 is 3. And if we go to Terribo's website.
A question to students, like what if it's out of fields? What will we do? Like if after adding we'll get like 18 or 19.
So if we decide to multiply, say 10 times 10.
Yeah, 10 times 10.
Right, and that is going to be log of 10. Log of 10 is going to be 20.
10 plus 10, right? 20. Yeah.
So what modulus do we take at? Well, we're doing the math now. So do we take that modulus 15 or modulus 16? Let's find out in our Jupyter notebook, shall we? And if we say we're going to use 16, we're going to take 20. If we take that modulus 16, that's either going to be a 6 or 4 if we take it modulus 16, right?
Yeah.
Or it's going to be a 5 if we take it
15.
Question, right? Which one is it going to be?
Yeah.
Let's go ahead and ask people to go ahead and tell us which modulus are we going to take. We did this in the previous lecture. I am not going to explain that to you right now. I'm just going to go ahead and run this, and you can figure it out as I find it in my example. So here's my example on the Gala table builder. I'll pull this up here. And here's my Gala table builder. So how many people vote for? Who votes for? Votes 5.
They vote 4.
Yeah, go ahead and type your answer in the chat. We're going to go down here. We're going to go ahead and run this code here to build the code. We'll build the table to dump it. We'll generate our tables. We're going to use 2 to the power of 4, and we're going to use 25, right? As our primitive polynomial. We'll run that. We'll get our log, anti-log tables. We'll see our anti-log table is 1, 2, 4, 8, 9, Baker, Fox, 7. 9, Baker, Fox, 7, 14 is going to be an E, so on and so forth. So it looks like we're in good shape so far. Let's go ahead and do the next one here, right? We're going to print our GF table size. We're going to dump our log, anti-log table. As we print that table out, we'll see that it resembles in much smaller font.
Yep.
The actual numbers 0, 1, 12, 2, 9, 13, 7, 3. So we successfully built that table. We can run our silly check code, and we can do our this, and then we can go ahead and print our multiplication table. And here we see 10 times 10 is 11, right? So the answer is we want to take this still modulus 15. 20 mod 15 is 5. Answer is use n minus 1 or 16 minus 1 equals 15. 20 mod 15 equals 5. We take 5, we go to the anti-log of that, we get 11. There's our 11. Oops, in our Galois field table right there, 10 by 10 is 11. Okay. So that's how we do our multiplication. Now for the people online, whoever's paying attention, is anyone still here? Or are you all just off doing your own thing? Good, I see some people are typing. So I'm going to ask you to go ahead and do, what shall we say? 6 times 3. 6 times 3.
Oh, you guys can unmute and answer the thing.
Or you can just type your answer in. What is the what is the log of 6?
Plus log of 3.
Log of 6 on this table, and log of 3. Log. And I'll leave those up. Log 6 is 15. There's 6. Let's look at this now. 6 is in the middle. That's the n column. The left column is the log. The right column. Oh, it's Ajay that typed it in. Yeah. And I fooled you too, didn't we? Right? If we want the log, we want to go to the left. Log is left.
I thought someone would correct it, but
Yeah. Oh, you were hoping someone would correct. Oh, you did it wrong on
Yeah.
purpose. I'm with you. I'm sorry.
Yeah.
Yeah. Okay. I do that too. Yeah. I do every time I make a mistake, I did it on purpose. I think he actually did do it on purpose. Okay. So anybody? Is anybody there?
Log of
There's our
6
table.
is 13.
Yes. Log 6
Log
is
of 3
13.
is 12.
Yeah, log of 3 is 12.
And log. So we add 12 and 13 and we get 25. So now we take that. What do we take that? 25.
If I mod 16 or 15 and minus 1.
What do we take 25 mod? Is something. Anybody?
16.
25 mod 16? No, I don't think so. We're going to take it. Nope. If we take 25 mod 16, we get, what do we get? 25 mod 16 is 9, right?
Yeah.
So if we take the anti-log of 9, we get 5. Well, let's look
5.
at our table here.
No.
So we just did 3 times 6. Where'd it go? 3 times 6, 6 over here in the 3's column. We say that should be 10. What do we do wrong? Again, the GF table size.
It should be mod 15 instead of 16 and minus 1.
But there is.
I think we have to do 25 mod 15.
Yes. So we have to take. Again, if the Galois field table size is 32, we take a modulus 31. If the Galois field table size is 64, we take it mod 63, so on and so forth. So we take 25 mod 15, we get 10. 10 anti-log of 10 is 10. It's its own inverse, its own log and anti-log. Again, we look down here, we say 6 times 3, we get a 10. We say 3 times 6. Of course, we can do it in either order, right? We get the same thing.
Yeah.
6 times 3 is 10. So 6 times 3. So we'll go out, scroll down here. We'll put on this short, so 6 times 3 is 6.
Okay.
That's 13.
13, yeah.
13 plus 12
plus
equals 25. 25 mod 15 equals 10. Anti-log.
10. It's 10.
And that fits on our table that we calculated.
Yes.
So it's nice to have things automated. When we start doing this by hand, we'll make mistakes, right?
Yeah.
So 25 mod 15. So we took 25 mod 15. So we can go more if we want to, but I don't think we
No,
need
that
to,
should be
right?
fine. Yeah, that
Good.
should be fine for midterm at least.
Yeah. So we're going to have a question like that on the midterm. We're going to say, so for instance, as we're building this table, right? This is strictly at each step in this table that we're building. The only thing that matters is where we are. If we've built 15, regardless of where we are, we have a primitive polynomial, whatever it happens to be. We'll build every single one of these if we actually have a good primitive polynomial. We'll just build them in different orders. So you might find a question on the midterm saying, okay, we're building a primitive or a table of logarithms, anti-logarithms. We just built the anti-logarithm for 6, and we got a value of 15. What comes next? Well, you don't know where in the table it is, but you can still figure out what the next thing is. You're going to take 15, right?
30.
15, you're going to take 15, you're going to double it, you're going to get 30. Right? You're going to say
mod
30 is out of range, so I'm going to
15.
XOR it with my primitive polynomial, whatever I happen to be using.
X.
And that'll bring me back in range, and so on and so forth, right? So, okay.
So I actually have a question in quiz, but we'll do the quiz in the next class, so that's fine.
Okay. Quiz is the next class. Okay.
Yeah.
Okay. Sounds like a plan.
Yeah.
Are we good? Did I do as well as you did yesterday?
Yeah, that's the same thing I did. It is the same
Okay.
primitive polynomial I took. Yeah.
Yeah. Okay, and I will go ahead and save this thing. I guess Paint was not the right thing to do. Is just go to a spreadsheet, huh?
Yeah. Yeah.
All right, so we'll go ahead and do a save on this, and I will post this on the lecture slides too.
Mhm.
Okay. All right. I'll stop sharing my screen then, and I guess we'll call it good for the day. Go ahead and take attendance.
Wait. Yeah, just type in your name in the chat box, and that's good for today's attendance. I'll stop recording this one now.